Hello everyone. I'm Dr. Pratibhadevi. Now let us have a presentation on the rectifiers. What is basically a rectifier? Rectifier is a electronic circuit which converts alternating current into the DC current that we will say as the AC to DC converter. It is going to be used in the power supply unit. It is a part of the power supply unit. There are two kinds of rectifiers. The category of rectifiers are half wave rectifier and full wave rectifier. So the complete power supply unit is going to be shown with this block diagram. That is in what AC supply is available in our India is with a rating of 230 volts and 50 hertz. That is the alternating current. It is passed on to the transformer to step down the voltage from higher voltage to the lower voltage based on where 5 volts is required or 10 volts is required or 12 volts is required. The step down transformer of that rating is going to be used. Then the next stage is a rectifier. Next stage is going to be called as a smoothing or the filtering. So its next stage is the regulator. Regulator provides the voltage without any variations with respect to variation in the different parameters, and then it is given to the load. Load, for example, I can give what can be the load. It can be a fan, it can be a refrigerator, it can be a washing machine, or it can be a mixture, or it can be a any of the machines working with the DC power supply, or it can be your mobile charging also. Okay, so this is about the what happens to the signal at each of the stages. It is also given now. This is the original signal AC. This is a transformer output. A transformer is AC to AC converter. Then it's once it is rectified, it is converted into pulsating DC. Then that is smooth. After the smoothing or filtering, it is going to be pulsating DC with the filtering. Means it is a impure DC only. It contains a little part of the AC also. So then after regulation, it is going to be a completely pure DC. The rectifiers, I told already, it is a AC to DC converter. The types of rectifiers are going to be half wave rectifier, full wave rectifier. In full wave rectifier, there are again two types. One is a center tap rectifier and another is a bridge rectifier. Let us see first what is half wave rectifier. The circuit diagram of a half wave rectifier is given here. It makes use of a single diode. First, AC is given to the transformer. Transformer output is given to the diode and the load resistor RL. So the working principle, during the first half cycle of the input, the diode acts as a short circuit or the closed switch. It is going to act as a, it is passes the input to the output. The input half wave is available at the output. But whereas during the reverse bias or during negative half cycle of the input, diode is getting reverse bias and it is acting as an open circuit. There is no output voltage. Output voltage is 0 here. The circuit actions are converted into the waveforms. So you can see here during positive half cycle, the output is positive half cycle, load current as well as the load voltage. And during negative half cycle, load current as well as the load voltage both are 0. And the last waveform is here PIV. PIV stands for a peak inverse voltage. That is what is the voltage across the diode when diode does not conduct. That is here equals to EVM. So these are the expressions for the different parameters of the circuit. There is a peak value of load current IM, IDC, and as well as the IM in terms of RF, RL, and RS. The RF stands for the forward resistance of the diode. RL stands for the load resistance. RS stands for the source resistance. The two factors or two parameters are going to be important with respect to rectifiers. That is the rectifier efficiency and ripple factor. Rectifier efficiency is the DC output power to AC input power, and that is PDC by PAC. And ripple factor is going to be RMS value of AC component of output to the average or DC component of output ratio. For half wave rectifier, the efficiency is going to be 40.6%. Always efficiency is expressed in the percentage. And the ripple factor is going to be 1.211 for the half wave rectifier. Ripple factor means what? That is the residual amount of the AC that is going to be a ripple factor, or the amount of AC present in the converted DC is going to be a ripple factor. Next is the peak inverse voltage. As I told, peak inverse voltage is the voltage across the diode when it does not conduct. That is going to be PIV. Here it is in half wave rectifier, it is going to be EM. What are the disadvantages of half wave rectifier? Then because of these disadvantages, we are going for the full wave rectifier. The ripple factor of half wave rectifier is 1.21, which is quite high. The output contains a lot of ripples, that is the AC component. The maximum theoretical efficiency is 40% or 40.8%. The practical value will be quite less than this. This indicates the half wave rectifier is quite inefficient. So we are moving to the full wave rectifier. Full wave rectifier is containing the center tap transformer as well as the two diodes are required here. So this is complete how exactly the input output response, what will be the output response of a full wave rectifier. Here both the cycles of the input are converted into the output because one diode conducts in each of the cycle. During positive half cycle, the upper diode conducts, lower diode doesn't conduct. So output is going to be equivalent to the input. During negative half cycle, the lower diode conducts, upper diode doesn't conduct. And the response of output during negative half cycle is going to be like this. The waveforms with respect to the input are going to be like this. IM and EM are going to be this. This is a IM completely for whole cycle. This is EM completely. This is current. This is voltage for whole cycle. So both the cycles are getting converted into DC here. So efficiency is going to be here double as that of the half wave rectifier. The expression and calculation of the efficiency for full wave rectifier is shown here, that is 81.2%. And the ripple factor is going to be lesser than the half wave rectifier. That is, the ripple factor is nothing but amount of AC residual, that is 0.48. What is peak inverse voltage here? Peak inverse voltage is going to be 2 VM because the center tap transformer, both the side voltages are going to appear when the diode doesn't conduct. That's what it is going to be. Peak inverse voltage is going to be 2 VM. Next, let us see what are the advantages of full wave rectifier. Efficiency is higher, the larger DC power output, the ripple factor is less, but still it is having certain disadvantages. Disadvantages of full wave rectifier, that too center tap is that PIV rating of diode is higher. Higher PIV diodes are larger in size and costlier. The cost of center tap transformer is also high. Because of these drawbacks of this full wave rectifier, we are going for the bridge rectifier, bridge full wave rectifier. Here 4 diodes are used, so not a center tap transformer is used. So here in each of the input cycle, 2 of the diodes conducts. The equivalent working circuits are shown here. In positive half cycle, these 2 diodes conducts, that is D1 and D2. D3, D4 doesn't conduct. The output is same as the positive half cycle. During negative half cycle, the D3 and D4 conducts. D1, D2 does not conduct. The current flows in the circuit in the same direction as that of the first half cycle. So the output current appears during the negative half cycle of the input. So these are the waveforms. Waveform remains the same as that of the center tap rectifier. These are the expressions. The ripple factor efficiency remains the same for both the types of a full wave rectifier. Then advantages of bridge rectifier over the center tap transformer is it does not need the center tap transformer secondary. The transformer secondary voltage of CT rectifier is 2 VM, where 2 VM or 2 EM both are same. V and E both can be used to write the same thing. And stepping up or stepping down now voltage is not needed. We may even do away without transformer also for the rectification. That is the one added point here. Each diode in center tap transformer has PIV rating of 2 VM, whereas diodes in bridge rectifier needs PIV rating of VM only. Hence, the diodes for use in center of transit rectifier are costlier than meant for bridge rectifier. Disadvantages. What are disadvantages? It requires 4 diodes. Definitely, a hardware requirement is more. 2-pitch conductor in alternating cycles. This creates a total voltage drop of 1.4 volts if silicon diodes are used. Therefore, this creates a problem if low DC voltage is required. The secondary voltage is low and a 2-diode voltage drop of 1.4 volts becomes significant. Here, if it is a power dissipation or heat generation is considered, this is going to be a drawback. This is a comparison of half-wave rectifier, center-tap full-wave rectifier, and bridge rectifier for different parameters like, so what is the form factor, ripple factor, efficiency, output frequency, etc. So these are the different parameters. Thank you.